Welcome back, students. Today we are going to continue solving systems of equations. So far we have done so by graphing, by substitution, and today you're going to learn a third method called elimination. So real quickly, I have two examples. Actually, it's the same example solved using the previous two methods. So if we were given this system right here, if we were given these two equations, so two equations, and notice how they have two variables, x and y. So if we have 4x plus y equals 3 and y equals x minus 7, one way we can solve them is by graphing. So what we would do is we take our first equation, so 4x plus y equals 3, and we solve for y. So we move 4x over by subtracting 4x. We identify the number in front of the x as negative 4, so the slope is negative 4 over 1. The y-intercept is 3. So we graph the point 3, we plot that point on the y-axis, and then we move down 4 since it's negative, and then to the right 1. So our line is going down. But it's a system, which means not only do we have one line, but we have two. So then the other line, y equals x minus 7, we identify the slope. That's already solved for y, so we look for the number in front of x for the slope. That's 1 over 1, or just 1. And the y-intercept is negative 7. So on the y-axis, we plot a point at negative 7. We go up 1 to the right 1, up 1 to the right 1. We plot as many points as we can. But what we're looking for is the intersection. To be a solution means to be a point on the line. So a solution to the system means it has to be a point on both lines. So where do these 2 points intersect? Well, right here at this point, right here. So the solution is that ordered pair. So make sure that you put parentheses, and this is at 2, negative 5. Well, here is that same system that is solved by substitution. So 4x plus y equals 3, y equals x minus 7. The way this system was presented to us actually made it pretty nice for substitution, because the first equation had both x and y on the same side, but the second equation already had y by itself. So we identify what y is equal to, which is x minus 7, and then you substitute or you replace that for the y in the other equation. And then you go through and you solve your equation, and then you plug it back into one of the originals, and then you solve for your other variable. And we get the same ordered pair because it's the same system. So either of these methods is just fine. Sometimes graphing won't always work because the intersection isn't at a nice integer value. So then substitution is a good method to be able to use. But sometimes substitution isn't the nicest because you have to work with some nasty numbers. So if your equations are not set up for substitution, then maybe this third method would be the best method. And this method is called elimination. And why is it called elimination? Well, because your goal is to get a variable to eliminate. How you will do that is by these steps. Line up your equations, and then you're going to add your equations together. So that means that you may need to change all of the signs of one of the equations to make them to cancel. Add the two equations together, one of the variables cancels, see what you're left with, and then solve the remaining equation for that variable. Plug it back into either of the original equations, and then, if it's possible, write your answer as an ordered pair. So what I'm going to do is I'm going to resolve this same system that I solved by graphing, that I solved by substitution. I already know my answer is going to be 2, negative 5, but let me show you this new method. So step number 1 is to get the system lined up. So what that means is vertically, these need to be the same terms on top of each other. So right here I have 4x. That means right underneath it, I should have my x term. So to move my x from the right hand of the equal sign to the other, I'm going to have to subtract x on both sides. So when I move x over in my second equation, that will now give me negative x, and then I had a positive, so plus y, equals my x minus x cancels, so that will be equal to negative 7. So now my goal is to add these two equations together to get one of the variables to cancel. So if I try adding these two equations together right now, 4x plus minus 1x, 4 minus 1 would give me 3x, and then 1y plus 1y would give me 2y. None of my variables canceled. So that means what I need to do is I need to go through and I need to change the signs of one of my equations. So what I'm going to do is change all of these signs. So hopefully you're using a pencil. I'm going to change this minus x to a positive x. I'm going to change this positive y to a negative y. And then I'm going to change this negative 7 to a positive 7. So now I'm ready to retry adding my equations together. So 4x plus 1x, so 4 plus 1 would give me 5x. 1y plus negative 1y, those cancel out, they eliminate. Bring down the equal sign, 3 plus 7 is 10. So now I have this equation, 5x equals 10. To get x by itself, it's being multiplied, so I will divide both sides by 5, and I get that x equals 2. That's only one of my coordinates. I need to find the other coordinate. So then what I do is I take that and I plug it into one of the original equations. Doesn't matter which one. And I think I'm going to choose the y equals x minus 7. So I'm going to replace x with 2 since I now know that x is 2. And I can use Desmos, but 2 minus 7 is going to give me negative 5. And since this gives me a nice ordered pair, I need to write my final answer as an ordered pair. This system would be classified as consistent and independent, which means the two lines intersect at the ordered pair 2, negative 5, which is what we saw when we solved by graphing up here. Let's do some more examples. All right, so this first example is actually just the example that I did up above, so I'm not going to redo it. But this second example, I'm going to try to go ahead and add the equations together. And if one of my variables cancels, I can keep going. If not, I need to go back and change the signs on one of the equations. So I have 1x plus 2x, which will give me 3x. I have negative y plus y, which cancels out. I bring down the equal sign, and 11 plus 19 is going to give me 30. So I was able to add these two together because they were already lined up. When I added them, my y's canceled out. So now I'm left with one equation with one variable, which I can solve. So to get x by itself, it's being multiplied. So I'm going to divide both sides by 3, and I'm going to come up with x is equal to 10. So of my ordered pair, for my ordered pair, this is telling me my x coordinate is 10. I need to figure out what the y coordinate is. So now what I need to do is I need to take this value of 10 and plug it into one of the original equations. It does not matter which one I do. If I take x minus y equals 11, I can erase and replace my x, substitute in my value of 10. So I put in a 10 right here. 10 minus y equals 11. My goal is to get y by itself. So to move a positive 10 over, I will subtract 10 on both sides. 10 minus 10 cancels. I have negative y is equal to 11 minus 10 is 1. Then to divide, to get y by itself, make it so it's positive, I'm going to divide both sides by negative 1, and I get that y equals negative 1. So my ordered pair, once again, had I graphed these, I would have had two lines that would intersect at a single point at the ordered pair 10, negative 1. So this solution would be consistent and independent. This next example, again, what I'm going to do, I should check to see if my equations are lined up. So y on top of y equals x's and then the constants. Okay, so it is lined up a little bit different than how the other ones were, but it's still okay because we have like terms right on top of each other. So next what I'm going to try to do is add the two equations together, and 1y plus 1y is 2y equals 2x plus 2x is 4x. Nothing canceled. So I'm going to have to go back, and what that means I need to do is change all of the signs on one of the equations. So what I'm going to do is I'm going to change this y to become a negative y. I'm going to take this 2x and make it a negative 2x, and I'm going to take this negative 11 and make it positive 11. So now what I'm going to do is add them, and hopefully something will eliminate. And y plus negative y does eliminate. Bring down the equals, and then 2x minus 2x, that also eliminates. Ooh, and then 5 plus 11 gives me 6. All right, so something very interesting happened here. Actually, two things. One thing is on the left-hand side, we don't have any value. We always need to have something. So if you have nothing left, if everything canceled, use the number 0. Equals, Then what was different about this problem is the fact that not just the y values, but the x's canceled as well. If you go back to your substitution, we learned that if both variables cancel out, it means you're either going to have no solution, which means they were parallel lines if you graphed them, which means they will never intersect, or they are the same line, which means that they share infinitely many points. So there are infinitely many solutions because any point on that line is a solution. So what we need to do is we need to determine, is this a true statement or is it false? So is 0 equal to 6 true or false? Well, that one is false. So because it's false, that means this is going to be no solution. Had we graphed these, okay, so had we gone and solved this one by graphing, we would have had a slope of 2 for both of them, but different y-intercepts. So same slope means they move the same way, but different y-intercepts means that they start differently. So those would be parallel lines, which means they never intersect, which is showing us that we are correct when we said no solution. All right, the next one, 4j over 4j, k over k, my equals, and then my numbers without variables, the constants come next. So what I'm going to do is I'm going to try to add the two equations together. 4j plus 4j is 8j, 1k plus 2k is 3k, and nothing canceled, nothing eliminated. So I'm going to erase, and then I'm going to go back through, and I'm going to change the signs on one of my equations. Doesn't matter if I do my top or bottom. So I'm going to go ahead and do bottom again. So I'm going to make this negative 4j. I'm going to make this a negative 2k. And then I'm going to make this a positive 10. If you want to completely rewrite it, you can completely rewrite it. Okay, and then what I'm going to have is 4j plus negative 4j, which cancels out. I have positive k plus negative 2k. So I can think of this as 1 minus 2, which is going to give me negative 1, keep the variable k, equals negative 9 plus 10 is positive 1. Divide both sides by negative 1 because I want to get k by itself, and this is going to give me k equals negative 1. That's one of my variables. I need to get the other one. So my original equation, one of them was 4j plus k equals negative 9. So I'm going to erase and replace k with negative 1. Now, since this is in the middle of an equation, I'm going to go ahead and put parentheses around it. And this is going to give me 4j plus a negative 1 is the same thing as just having minus 1 equals negative 9. I will add 1 to both sides. And this is going to give me 4j is equal to negative 8. Divide both sides by 4. And I get that j equals negative 2. So now I need to write my solution as an ordered pair, because once again, it's possible since it means that my two lines would intersect at a single point. But which one comes first? Okay, this isn't X and this isn't Y, so which one comes first? Just go in alphabetical order. So if you need to sing your ABCs, sing your ABCs. You don't want me to sing the ABCs to you. So I'm going to go ahead and just put them in alphabetical order. This would be negative 2, negative 1. Last but not least, let's go ahead and do a little story problem. So this is one of the basics of the story problems because it's just a translating from English words to math words. So English sentences to math sentences, aka equations. So first thing that you should do when you're doing a math story problem is basically read through the problem and then find the question, because that's going to help you define your variables. So it says the sum of two numbers is 34, their difference is 8. What are the two values of the numbers? This is what we're trying to find. What are the two values of the numbers? So our variables, you can use whatever letters you want. The standard are x and y. I'm going to let x represent the first number. And then that means I'll let y represent the second number. So my two equations, my first sentence says sum. Sum means addition. The sum of the numbers, so that means x plus y, is, so equals 34. My second sentence says their difference is 8, so that means x minus y equals 8. This one's actually perfect for elimination. The reason why it's perfect for elimination is because my x's, my y's, my equals, my constants are already lined up. When I go to add my two equations together, I get 1x plus 1x, which gives me 2x. 1y minus 1y cancels out. Bring down the equals, and then I'll have 34 plus 8, which is going to give me 42. Then divide both sides by 2, and this will give me x equals 21. So one of the numbers is 21. The first number is 21. My second number, I know that their sum, so x plus y was 34. So I know that 21 plus the second number is 34. So maybe you can do this in your head, but if not, solve it algebraically by just undoing the operations. So 21 minus 21 cancels. This will give us y is equal to, and then 34 minus 21 is going to give us 13. So you can double check, is 21 minus 13 equal to 8? And the answer is yes. So then the final thing that we'll do is write this as a sentence answer. So we'll put the first number is 21 and the second number is 13. Makes it very easy to be able to write our solution as a sentence because we've already defined our variables. So first number is 21, y, the second number is 13. And that is elimination.